Hello class, welcome to lesson 8.1 on dilations. So we're going to talk about this special transformation. So our essential question today is, how can dilations be used to enlarge or reduce geometric figures by a scale factor? Okay, so for this transformation, a dilation, how can it be used to enlarge or reduce geometric figures by a scale factor? So remember that we had different types of transformations. We had rotations, we had translations, and we had reflections. Now those transformations were referred to as rigid transformations. Okay, so again, think rotation, think reflection, and think translation. Those are referred to as rigid transformations. Rigid because they do not affect the shape or the size of the original figure. It maintains rigidness, so it becomes the same size. Now this new transformation is non-rigid. Non-rigid meaning that it's a transformation that changes the dimensions. It changes the dimensions of a given figure. All right, so think of like a rubber band. You have a rubber band and you stretch it, it's gonna enlarge it. If you compress it, it's gonna be reduced in size. So think of it like that. Think of dilations, non-rigid transformations as that. Okay, so a dilation specifically is a non-rigid transformation, enlarges or reduces a geometric figure. Okay, so it enlarges it or reduces it. When a figure is enlarged or reduced, the sides of the image are proportional. Okay, so when you enlarge or reduce a figure, the sides are going to be proportional. All right, so if you ever try to re-image a picture, you start off with a certain picture and then you zoom in on it. It's still going to be the same proportions, but it's just going to be zoomed in. Okay, so that gives you an idea. All right, so the center of dilation is the center point from which dilations are performed. So you have something called the center of dilation, okay? Center of dilation is the center point from which dilations are performed. The scale factor, and let me put the dilations here. The scale factor of dilation is the ratio of the length of an image, so ratio of the length on an image to a corresponding length on the pre-image. Okay, so in other words, the scale factor, we usually use K for that, by the way. So the letter K usually denotes the scale factor. And so what we mean by that is we take the image divided by the pre-image. So the image length divided by the pre-image length. Okay, so that's how we get our scale factor, K. All right, and we'll look at that in the example coming up, okay? The value of K determines whether the dilation is an enlargement or a reduction, okay? So the value of K determines whether it's enlargement or reduction. A dilation with a scale factor greater than 1 produces an enlargement, or an image that is larger than the original figure. A dilation with a scale factor between 0 and 1 produces a reduction, which is an image that is smaller than the original figure. All right, so let's look at an example of this idea of the scale factor of dilation. Okay, so determine whether the dilation from triangle ABC to triangle DEF is an enlargement or reduction. Then find the scale factor. Okay, so you're going from triangle ABC to triangle DEF. Okay, so it's saying you're going from this to that. So this is saying that triangle ABC is the pre-image. So you're going from here to there. And notice that is a reduction, right? So it says triangle DEF is the image. It is smaller. Since it's smaller, then it has to be a reduction, right? So we're going to say this is a reduction. The scale factor is equal to the side length of triangle DEF divided by the corresponding. So if we find the scale factor, remember it's image divided by pre-image. Well, the image is this red triangle, the smaller one. And so the image length is 2 centimeters. And then the corresponding length to that is the 6 centimeters. Remember, it's corresponding because, well, they match up. So remember, AB matches up with DE. So make sure you do the right ones, okay? ABC matches with DE in this transformation map here. Okay, so 2 divided by 6, so it's 2 over 6. But that's the same thing as 1/3, right? So 1/3. If you divide both things by 2 here, we get our scale factor. All right, and that's it. So remember, the scale factor is less than 1. That means it got reduced in size. So that's great. All right, example 2. Find and use a scale factor. So it says Jalal's printing a banner for his school's wheelchair tennis team based on the design shown below. By what percent should Jalal enhance his design? So that the dimensions of the banner are 5 times that of the original design. What will the dimensions be of the banner? Okay, so we want to enlarge it. So we want to zoom in on it, make it bigger, right? And it says enlarge it by 5 times that. So 5 times that means 500%, okay? So the scale factor is 5 times 100% or 500%. Clearly that's an enlargement, right? An enlargement with a scale factor of 5, okay? So that means that K equals 5. So now we can find the dimensions of the enlarged image using the scale factor. So 6 times 500%, that's just 6 times 5, guys. So 6 times 5 for this example, which is equal to 30 inches. And then 14 times 5, which is 60, should be 70, yeah, 70 inches. Okay, so the banner must be 30 inches by 70 inches. All right, really straightforward. Okay, so let's talk about dilations on the coordinate plane. So now you know a new transformation known as a dilation. And what that does is it enlarges or shrinks a given figure. And it's referred to as a non-rigid transformations. Okay, this is an important study tip. Unlike rigid transformations, dilations only preserve the angle measures. Okay, so if I take for example, a rectangle and I enlarge it by a factor of 2, let me try to draw this a little better here. So if I get for example, a small rectangle and I do an enlargement by a scale factor of 2, well, that means everything is twice as large, right? So now this is a scale factor of 2. And so, but notice that the angles are still the same, right? So the angles, this still remains a rectangle, even if I enlarge it. So the angle measures are preserved, right? So angles, it preserves angle measures, but it does not preserve the side length. So this side length was 10. When if I double it, it'll be 20. If this side length is 5, then when I double it, I get 10. So sides are not equal, right, to the side lengths of the pre-image. So the side lengths are not equal. So therefore, dilations do not preserve length, but they do preserve angles, okay? All right, so to dilate a figure by a scale factor of K with respect to the center of dilation 0, 0, which is the origin, guys, multiply the X and Y coordinate by K. That's all you have to do. So just multiply the X and the Y coordinate by K, and that gives you an enlargement. So for example, if the scale factor of K equals 3, then the transformation rule is XY maps to 3X times and then 3Y. 3 times X and 3 times Y. That's how you get from this blue to this purple. So if this coordinate, for example, is 2, 1, right? 2, 1, then when I multiply it by 3, right? So 2, 1 multiplied by times where K equals 3, we get 3 times 2 and then 3 times 1. But 3 times 2 is 6 and 3 times 1 is 3. So then the new R is going to be 6, 3. 1, 2, 3, 4, 5, 6. 1, 2, 3. So this is 6, 3. That's really all there is to it. Just make sure you triple the X and Y coordinates because K equals 3. And notice that this length, this is a certain length, but and it's 3 times long in this line here. So 1 length, and then 2 length, and then 3 length. You can see there's 3 of those stacked. That's hence is 3 times bigger, and that's true for every line that you see here. For this, when you see these lines here, from the center to the point on the triangle. Okay, so let's move on to the next point here. Let's look at one more transformation rule. And this is a transformation rule where you dilate by a scale factor, just like we did before, but this time you're not doing it from the origin, okay? So this is not the origin, whereas before it was the origin. So let me emphasize that. So the center of dilation was at the origin here. Here, the center of dilation is not at the origin. So of course it's going to be a little bit more complex because you're not doing it at 0, 0, you're doing it at a different point. Okay, so it's a formula. It looks a little complicated, but we can use it since we know what it is. So that's your formula. Okay, so just box that just to make sure that you know you have it. So in this case, remember, since you're not rotating, you're not doing it from the origin. A and B are your center of dilation. Okay, so for example, the image of triangle DEF dilated by K equals 1/2. So I'm going to circle that. That's important. K equals 1/2. That goes in to here, right? And then we have D. You want to do it centered at D is 4, 2. So A is 4 and B is 2. Okay, so that's what we're going to plug into there. So in this example, the transformation XY maps to K is 1/2. So we got 1/2 times X minus 4 plus 4, comma, and then 1/2 is K, right, times Y minus B is 2 plus 2. This is the transformation rule for this example, okay? That's how you use that. Now, if you were doing it for D, or for, let's say, E, then you would plug in the coordinates of E into that, okay? So let's just do E, for example. So E, the coordinates of E are 1, 2, 1, 2, 3, 4, 5, 6. So 2, 6. So in that case, if I do it for 2, 6, well then this is going to be A, this is going to be B. Or I'm sorry, not A and B. This is going to be X and this is going to be Y. Sorry about that. So we're going to plug that in there. So we get 1/2 times 2 as X minus 4 plus 4. 1/2 times Y is 6. 6 minus 2. Plus 2, and then we just do the math. So we got 2 minus 4 is -2. -2, half of -2 is -1. -1 plus 4 is 3. Okay, so I'm not going to show all the work there just because I don't have any space here. 6 minus 2 is 3. Then we got 3 times 1/2. That's 1.5. 1.5 plus 2 is 3.5. Okay. So if I do that, oops, I did bad mental math there. Sorry about that. 6 minus 2 is 4. I said it was 3. 6 minus 2 is 4. Half of 4 is 2. 2 plus 2 is 4. Sorry about that. Okay, that's better. All right, so then we look here. This is E prime. Well, this is E prime, which is 3, 4. Okay? All right, so now that makes sense. All right, so there gives you an example. I gave you examples of each. So let's look at the example 3. So triangle TRS has the following vertices. Find the coordinates of the vertices after each dilation. So centered at the origin, K equals 1/2. So we're doing it at the origin. That means we're going to use the rotation rule, right? The rotation rule here. So this is the rule for rotation, or for, I said rotation, dilation about the origin. Okay, so you just got to take the coordinates and multiply them by K equals 1/2, right? And that's what we do here. Half of -4, half of -5. All right, half of 0 and half of 6, which is 0, 3. So we got the answer there. We got here. These are the answers. I'm just going to box the answers. And then we got half of 4, right? And then half of 3. Half of 4 is 2, and half of 3 is 1.5. Okay? That's how you do it. Really simple, guys. Now, when you get to the centered at R, now R, remember, is 0, 6, okay? So if you're centering at R, okay, you got to be careful. R, they said, was 0, 6. So this is going to be X, is going to be, or this is going to, wherever you center it about, the center of dilation, that's going to be your AB. So this is your A, and this is your B in the formula. Okay, so this is the formula right here. All right, so essentially we're going to take 0, plug it in for A, and then 6, we're going to plug it in for B. And then your X and Y are dependent, are the coordinates that you're going to use. Okay, so we got our A is 0 and our B is 6. That's what we said, right? So we put that in there. Now this is going to be X, Y. So let me write down the generic transformation. Okay, I'll do it down here just so we have it. Okay, so we got X, Y approaches or maps onto. Now K is a scale factor of 3, so that's K. Okay, so we got, so let me just write K equals 3 because that's what they told us there. Okay, so K, 3 times X minus A, 0, plus 0, and then K is 3 times Y minus B, which is 6, plus B, which is 6. And then let's just clean this up a little bit. So this really becomes 3, I'm just going to say that it's equal to 3, X minus 0 is just X, and then plus 0 doesn't really do anything. So it's just going to be 3X. And then we got 3Y, and I'm just going to leave this as 3 times Y minus 6 plus 6. Okay? All right, so then you can kind of see how if you have this as X, then you just plug in -4 into there, and -5, you plug it in for Y, right, for T. And so that's what we're doing, okay? That's how they get this. And so this is going to be my answer for T. Now they're going to have us do R now. So this is going to be my X, this is going to be my Y. So plug in 0 in for X, right? And then this is going to be my A, which is 0. And then we got 3 times my Y, which was 6. Minus 6 plus the B, which is 6. But we know that 3 times 0 is just 0, right? So it's going to be 0. And then 3 times 6 minus 6 is 0. 3 times 0 is 0. And 0 plus 6 is 6. So we get our R prime. Okay, I highly suggest doing this on your own off to the side because the book kind of writes down the steps, and so it can kind of be a lot to see at first. But I suggest just kind of doing off to the side. Don't even look at what the book's doing. See if you can apply this formula and see if you can get it. Okay, rather than just kind of relying on what the book's doing here. Okay, so we got for this now we got our new X, our new Y. So we got 3 times X, which is 4, right? So 3 times, and then let's just follow this template. 4 minus 0 plus 0. Okay, so 3 times 4 minus 0 plus 0. I'm using this first template right here. Okay, and then we got 3 times Y minus 6, but Y is 3. So 3 minus 6 plus 6. But then we know that 4 minus 0 is 4. So 3 times 4. And then we got 3 times 3 minus 6 is -3. All right, let's do the math. 3 times 4 is 12, right? Okay, and then we got 3 times -3 is -9. -9 plus 6 is -3. Okay, and that's my third coordinate. Okay, hopefully that made sense. The next problem is going to be a practice to make sure you understand how to use the formula. So go ahead and pause the video and see if you can try it. All right, so let's do the check. Hopefully you pause the video and give it a try, as I mentioned earlier. So again, we're going to need to show our work, do the math. We know the formula, right, because they gave it to us. Now it says we're centering at the origin with k equals 4. So, all right, so remember the formula for origin. xy maps to kx, ky. Really simple, just multiply the coordinates by k. So for the first coordinate, x is 3, -4, and we're doing multiplying this by k. All right, so remember we got k equals 4 here. So I'm just going to put k equals 4. That's what we're doing. Okay, so that means that we're going to do 4 times 3 and then 4 times -4, right? And so that's going to be 12. Well, let's just put in the answer here. So we got 12, -16. So that's our work for that. And then y is 6, 5. Multiply each of these by 4. So 4 times 6, 4 times 5. And so that gives us 24 and 20. And then last one, z is 8, -2. that maps to 4 times 8 and 4 times negative 2. So we got 4 times 8, that's 32, and then we got 4 times negative 2, it's negative 8. Okay, all right, so hopefully that made sense. Now let's do part B and short work for that. So here k is equal to 2. Now remember the formula, xy maps to, this is the scale factor k, is going to be k times x minus a plus a, k times y minus b plus b, right? Okay, so there's our formula. And here our center of dilation is y. So the coordinates of y are 6, 5. And so this is going to be my A. This is going to be my B. And I'm going to plug those in colored. And I should have really done that for here, the scale factor. So I will do that for part B, but really for the scale factor, I'm just going to put the color for the scale factor, right, as well. So here the scale factor is 2. All right, so let's plug it in. Let's do the first coordinate. So we know x is 3, negative 4. So that's going to be our x and y, okay? So this is going to be little x, little y. So I'm going to put those in there in black. The rest of them are going to be colored, okay? So, all right, so k is 4, or 2, sorry, in this example. So 2 times x. Now we're going to plug in x, which is 3, minus a. A is red. A is 6, if you recall. And then plus 6. Let me just put the plus sign there. And then k is 2 times y is negative 4 minus, and then we got b in purple, that's 5 if you recall. That's our center of dilation, plus 5. Okay, close. All right, and then that's how we do it. So we're going to set this, we're just going to figure out what this is equal to. Actually, we could just do the math. Yeah, we could do the math. So 3 minus 6 is negative 3. Negative 3 times 2 is negative 6. Negative 6 plus 6 is 0. So this is going to be 0, all right? Negative 4 minus 5 is negative 9. Negative 9 times 2 is negative 18. Negative 18 plus 5 is negative 13. And again, you can do this on the calculator, do it on Desmos or whatever. All right, so let's do y, and then we'll finish off with x. So y is 6, 5. Now here's the trick. Since y is our center of dilation, that means, is it really going to change? If you can use the formula and plug it in, however, you can save yourself some work. If you go back here, when we had r as our center of dilation, notice that the coordinates for r did not change, 0, 6, 0, 6. As long as that point is the center of dilation, it never changes. And so we really don't have to do the work for r, right? Or in this case, for y. Wherever you're centering the dilation, the coordinate remains unchanged. And so we can save ourselves some work and just put that as our answer, okay? It's unchanged because it is the center of dilation. Okay, all right, so let's look at the next one, z. So z was 8, negative 2. All right, so this is going to be our new x, this is going to be our new y, right? Again, using the color coding scheme that we have, k is 2 times x is 8. So then x minus a, right? So x minus a is 6, and b is, or an a is, yeah, a is 6 there. And then we got, for the next one, we got 2 for k times y, which is negative 2, minus b, which is 5, plus 5. Okay, so we got here, let's do the math. 8 minus 6 is 2. 2 times 2 is 4. 4 plus 6 is 10. Negative 2 minus 5 is negative 7. Times 2 is negative 14. Negative 14 plus 5 is negative 9. All right, so we got our coordinates. We got 6, 5 here, and 10, negative 9. Okay, hopefully that made sense, and I showed our work there. Okay, so let's wrap up the examples here. All right, so let's look at example 4. So this one is an interesting one because they want you to find the scale factor, and then they want you to figure out the center of dilation and then write the coordinate rule. So they only give you the 2 triangles and they say, okay, it's a dilation, but you got to figure out what kind of dilation is it. Is it enlargement, reduction? What's the scale factor? And what is the center of dilation? All right, so let's talk about how to do that. So first thing we want to do is pick 2 sides that correspond. So here, let's pick AB and A prime B prime. Just pick those 2 sides, and you want to figure out the length of those 2 sides. Remember, to figure out the length, you have to use the distance formula, right? So so we got A prime A prime B prime. And then A, B. So you want to figure out the length of those 2. Let's do, we know that A is 1, 2, 3, 4, 7. We got 7, 0. We got A prime is 1, 0. We got C prime is 7, 1, 2, 3, 4, 5, 6, 7, 8, 9. Or I'm looking at, I don't need C, I'm sorry, I just need B. So B is 8, 9, 10, and 1, 2, 3, 4, 5, 6. And then this is 10, 3. Okay, so we got the coordinates, so now we can, let's go ahead and write them down here. Oops, this is a tricky question. This is the origin right here, guys. This is O. So I didn't even see that. So the origin is right here. So this point right here is 0, 0. So this actually is 0, 0. So they're trying to trick you here. So this is 1, 2, 3. This is -3, 0. And then this here, this B is at 0, 2. All right, those are tricksters there. All right, so we got 1, 2, 3, 4, 5, 6. So we got 0, 6. Okay, so basically they just took everything and just made it so O is at the right corner. And then we have A prime is -9, 0. Okay, so let's write those down. So A is -3, 0. B is 0, 2. We got A prime is -9, 0. And B prime is 0, 6. Okay, so we got our coordinates, first thing, and then now we want to identify the lengths. Okay, so remember, use the distance formula. Distance formula is D equals square root. Okay, we got x2 minus x1 squared plus y2 minus y1 squared. All right, so if we want to do it for AB, then we're going to subtract the x coordinates for A and B, right? So we're going to subtract those x coordinates, and that's going to be 0 minus -3, and then we're going to subtract the y coordinates, so 2 minus 0. Okay, so that's how we do that. Subtract the x coordinates, subtract the y coordinates, and then we'll do that for the next one. So A prime, B prime, so subtract the x coordinates, you got 0 minus -9, and then subtract the y coordinates, 0, 6 minus 0. All right, so we got, remember this double negative turns into positive, so 0 plus 3 is 3, 2 minus 0 is 2. This is a double negative, so it turns into 9, 6 minus 0 is 6. Okay, so now we can do the math. 3 times 3 is 9, 2 times 2 is 4, so we got 9 plus 4 is 13. There's AB. We got 9 times 9 is 81, 6 times 6 is 36, so you get 117. Okay, remember this is the image and then this is the pre-image. So to get the scale factor, we have to divide the image by the pre-image. Okay, so we got image divided by pre-image. And so this is our scale factor, K equals image divided by pre-image. So, and 117 divided by 13 is 9, and the square root of 9 is 3. So that's my scale factor, K equals 3. The scale factor is 3. So that's how you find the scale factor. Just take any 2 corresponding sides and then figure out their lengths and then divide the image by the pre-image. All right, so now let's find, how do we find the coordinates of the center of dilation? So remember that formula we used earlier, this A prime formula? Or this formula where here. So we're going to be using that formula again, and that's going to help us find out A and B. Because remember, the center of dilation is A comma B. Remember that? So that was A, and this is B. Well, then this formula is going to help us find that. And we just found K, right? We just found it in the previous part, and K was equal to 3. So that's going to be in yellow. So we know K. We don't know A or B, right? So we're going to have to solve for red and purple. Okay, but we do know X and Y, because in this case, what we're gonna do is we're gonna say that this formula is equal to the transformation, which is negative 9, 0. So we're gonna say that this is equal to that. Okay, and then the X and Y is going to come from the original point, and you could do this for any of the points, but we're choosing A. Okay, if we choose A, then we have to choose A prime. So we got A and A prime. Okay, the image equals to this formula. Okay, so image equals this formula, and the pre-image coordinates are plugged in to the formula. So let me circle those. You plug those into there, and you plug this in to there. Okay, we got all the coordinate, we got all the points there. Okay, so let's plug it in. We got K is 3, right? That's what we said K was equal to. And so yeah, so K is 3. And we got negative 3 minus, there's that A again, plus A. We don't know what that is. And remember that this here was my X coordinate negative 3. And this is my Y coordinate Y. And then we got our B, which we do not know what it is. So that's going to be purple. Okay, that's our formula. Now what we're going to do is we're going to set this part equal to this part. Okay, and likewise, we're going to set those two parts equal. All right, that's going to help us solve it separately. So let's do negative 9 equals this part right here. And we're going to distribute. So negative 9 is that part equals 3 times negative 3 minus A plus A. Now distribute. So we get 3 times negative 3 is negative 9. 3 times negative A is negative 3A. We got negative 3A plus A, and then we got this negative 9. So I'm going to add this 9 to both sides, and it's going to cancel, right? And so we have here negative 3A plus A. That's an A right there. It's hard to tell. Negative 3A plus A is negative 2A. Now if I divide both sides by negative 2, that's going to turn to 0, right? So A is equal to 0. All right, so we got A. Now let's do the second equation. Remember, the second equation is 0 equals to that part. Okay. So let's solve for B, shall we? 3 distribute. 3 times 0 is 0. 3 times negative B is negative 3B. Now we're going to combine our like terms. Negative 3B plus 2B is negative 2B. Then we divide by negative 2 on both sides, but we know that that gives us 0. So B is equal to 0. That means the center of dilation is actually at the origin. It's actually at 0, 0. Okay. That's how you find the center dilation, guys. Now we can describe the dilation, put it all together. We have a scale factor of K equals 3, and it's at it's centered at 0, 0. Since that is the origin, that means we can use the formula for the origin, and so it's going to be xy maps to 3x, 3y. Remember where K is 3. All right, and that really is it for that example. And so now you try the check and pause the video. Okay, so let's do the check. This one, there's a lot of work that you need to do, but there's a way to simplify some of the work here. When you're finding the center of dilation, it probably will be easier instead of using the distance formula. Now you can use the distance formula, of course, guys, but just to make it a little easier for you. So just to make it easier for you, instead of doing the distance formula, you can just look at a specific side. Okay, so let's look at this specific side that does not require the distance formula. So if I do, for example, I do this side right here, compare that to this side right here. So now in the pre-image, it's 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, 6 units, right? In the pre-image, it's 1, 2. It's only 2 units, guys. So that means, remember, pre-image divided by image, right? So so if I were to show my work, we get K is equal to image divided by pre-image, sorry. So it's 2 over 6, and I really should use another color there. So let me do blue. Okay, so we got 2 over 6, and then which, if we reduce that, that becomes 1/3. All right, there's my scale factor. So that's half the battle here. And notice that I did that with a very basic line. I didn't have to use distance formula because it's completely horizontal. Try doing one that's vertical if you have a vertical one. Okay, make it easier for yourself. Now, for the center of dilation, we want to figure out what that is. We need to use that formula, right? So let me write that formula down just so that we have it. Well, first off, which points do we want to use? Let's just use D and D prime. Okay, so we're going to use D and D prime. So D is 1, 2, 3, 1, 2, 3. So this is 3, 3. That's D, and then D prime is 7, 1, 2, 3. So it's 7, 3. Okay, so this is 3, 3, and then D prime is 7, 3. So remember, we want to set the transformation is we do the image equals, and then the formula. Okay, the formula is let me just write down the coordinates. Okay, so D prime, which is 7, 3, that's equal to the formula K. Let's do that in yellow, right? 1/3. And yeah, so we got D equals K times parentheses X. Now this is going to be my X, it's going to be my Y, okay? So X minus A. Again, remember we don't know what A is. Plus A. And then K times parentheses Y minus B plus B. And then, so remember B, we don't know what that is. That's what we're trying to find. So we're going to set these equal. So this is going to be set equal to this, right? I might as well just plug in the things, honestly, there. Let me just do that here. So we got 1/3, sorry, for K. X, what's X? 3, right? So we got 3 minus A and A plus A. We got 1/3 times Y minus B. B is unknown. Oh, I forgot to plug in for Y, so let me do that here real quick. Y is 3, 3. Okay, so there's our formula, and then now we're going to set the 7 is going to be equal to this, and 3 is going to be equal to this, okay? So we got two different equations. So we get, so let me set the 7. So 7 equals, I'm not going to color code it anymore when I do this, okay? All right, so distribute. So 1/3 times 3 is 1, and then 1/3 times negative A is just negative 1/3. So we get 1 minus 1/3 A. Okay. All right, let's make sure we're good. 1/3 A plus A. All right, so we got 7 equals, now negative 1/3 A plus A is 2/3 A. Okay, so you basically got a whole minus 1/3. 1 whole minus 1/3 is 2/3. All right, then we subtract 1 on both sides to get 6 equals 2/3 A. And then you got to multiply, and might as well show my work here. So, and I'll show it in green. So minus 1, and then for this I'm going to multiply by 3 and then divide by 2. I'm going to multiply by the reciprocal so that these cancel, these cancel. Okay, and so that leads to A equaling 3 times 6 is 18. 18 divided by 2 is 9. That gives us my A. Let's do B. That's 3 equals to this formula. So 3 equal to 1/3 times 3 minus B plus B. Again, similar to with A, we distribute. So 1/3 times 3 is 1. 1/3 times negative B is negative 1/3 B plus B. We're going to combine these. Negative 1/3 B plus B. Again, it's 2/3. We got 2/3 B. All right. And positive 2/3 B. And then we're going to subtract 1 on both sides here. So we get 2 equal to 2/3 B multiplied by 3 over 2. 3 over 2. So these cancel. And got 2 times 3 is 6. 6 divided by 2 is 3. So B is equal to 3. All right, guys. So then that means the center of our dilation is 9, 3. Whew, that was a lot. So we got the center of dilation. We just got the scale factor, right, as well. So the dilation is centered at 9, 9, 3. Scale factor is 1/3. And if you plug it into the formula, remember it's scale factor times x minus a, but a is 9, plus a, which is 9, and then 1/3 times y minus b, which is 3, plus b, which is 3. This is our generic formula, coordinate rule. That's going to do it for the video, guys. Hope you found this useful, and as usual, I'll see you in the next one.